Okay, so this week I started with the Exercise 1, um, which was a debugging exercise where you had a lot of problems, um, like things not appearing on the screen, non-defined, NaN, not a number, and all those things. Since I finished it on Monday, I kind of forgot. Now we are Friday, but most of the problem and bit fixed only because they were like a typo. Most of the place had typo. I remember here you had an extra six, and we had to change it to five. Also, like it was missing a function and things like that. So you had to pay attention to everything and change it eventually to the good thing. And so residential, I don't know, 45, 41, blah blah blah. Then standard, then everything works. The prices are adapting, and I verified the calculation and it was correct. So that was for the first one. Then the Monty Hall problem, I used the three classes. The game one that is kind of big with all the function, the door, and the statistics. So the way I did it, I started by the game one, where I created a parameter change that I put it here in case that the player decide to change door through the games in the matter in the with the purpose to do 10,000 games without changing his first choice, his first pick, and another 10,000 game while changing his doors. So that was the parameter I made. Then I made an array of doors. And right after it's created, you have this initialize door function that I created here, where I basically just instantiate three doors with different number and different value. The false and true are if it has a car, and it has a third value of open, but that we don't change because at each start of the game it has to be closed. So every one of them is false by default. You initialize the door and you push it in. So in order 1, 2, 3, that will become in the index 0, 1, 2. Then this door pick, you run choosing door. This function I put it here, it's just the player choosing a door by random. So it does match random here by the length of the door array, which is 3. And you return that in the variable here, door index, which will be 3. So you put it here. That's what I return. One of those 3. Once it is done, this becomes not this becomes, but it becomes a door pick, and then I go to open go door. I run the other function opening go door. Which is because I didn't manage to randomize the door yet by Friday, so I kept the old structure where the door 1 and the door 2 is always the goat. So the goats. So in the index, the first one is 0. So if door 0 hasn't been picked, then open it. If it has been picked, then else in the case, then just open the second door, which is index 1, and return it. Then choosing final pick, you need the parameter change, and that will be used in the main. So in case you do the run where he changes his mind, then I did a for loop where I check by the door lengths and just checking one of them, each of them, with two conditions. The door cannot be opened yet, so exclamation mark. And also the door that you are on cannot be the door that has been picked. So there always at least one door that hasn't been picked by the player and that hasn't been opened yet. Then return this door. That's the door it'll take. Else, if you don't change, well, the final pick will remain the same door as the door picked at the first time. So that's what it'll be. Then you check at the end is winner right after the final pick. You check if is one, you run is winner, and you just return the final pick parameter. Is it car? Is it a car or it's not a car? And then you win or you lose. Then I create new statistic to initiate it, and the main function of the calculation are done in the main. So the first for loop is if the new game false is not changing, then if it keeps with the same door, I pass the whole parameters. So if at the end the is winner game is one is true, then just add them, push it in the array statistic of the game one with the same door, and if not, we'll push in the game lost. Yeah. Yeah. So then the other one is if it's true, if the new game is changing, then it's just the same logic, but in two different arrays. The games with door change one, and the game with door change lost. At the end, I try to output only the winning percentage of with or without changing doors. So the first three lines is total same. So the total of game played with the same door without changing, you just do the length of the door one with the length of the door lost together in a total. Then to the percentage, I just round the game door lengths divided by 100, multiplied by 100 and divided by the total same that we got just before. And I put it in a string with a concatenation and a percentage at the end. Then I console log it with the text that was required for not switching door. Same logic here, but with switching and then doing this. At the end, you have the main that is called, and you can change the number of game. Here I put 100,000, so it's way much more. I'm going to run it, and it gives what it expected. So 34% of the games were won when not switching door, and 67% of the game were won when switching door, proving the mathematical theory of switching door is better.